Welcome, NATE members, to today's webinar. My name is Todd Schleckaway, and I have the privilege of serving as the President and CEO of NATE, the Communications Infrastructure Contractors Association. We are really excited about today's webinar, discussing how applicable industry standards set up contractors, structure owners, and end users for success. We have a rock star panel for all of you to listen to today. Before we dive right in, I want to make a few housekeeping announcements. The panelists on today's webinar are really encouraging audience engagement and participation, and they will be taking questions at the end of the webinar. And so you can go to the chat box and GoToMeeting and type in a question, and we'll make sure to try to address it at the conclusion of the remarks by the panelists. And without further ado, it's my pleasure to introduce David Hawkins. He's the president of Paul J. Ford and Company. Dave is going to be facilitating the discussion and introducing the other panelists as a moderator today. So David, it's all yours. Thanks for joining us.
Great. Thank you, Todd, and good morning, everyone. Welcome to this webinar, and thank you for taking an hour of your day to be with us. We're going to be talking about compliance with TIA standards and how they set up contractors for success. But first, let's have a quick disclaimer here. Move this slide along. This webinar is intended to be used for informational and educational purposes only. The views and opinions expressed by the panelists in this webinar are their own and do not necessarily represent the views and opinions of NATE. So without further ado, let's meet our panel today of experts. Again, I'm Dave Hawkins, structural engineer and president of Paul J. Ford and Company. Joining us today is Justin Kisting, program manager, Proactive Telecom Solutions. He's also a field expert and a safety expert. We have John Bazzetto, PE, another structural engineer, vice president of structural engineering at Vertical Bridge, and everyman Ryan Carr, Eastern Market Director, Sabre Site Solutions, representing a fabricator, constructor, inspector, and everything related to the field. And he's got a great looking beard. So we're gonna go right into the next slide here. Note, this is not the mission statement of NATE or TIF. The panelists today represent various industry stakeholders, owners, engineers, safety consultants, fabricators, constructors, and inspectors. We've come up with this generalized mission for the purpose of this webinar, which is basically to design, build, and maintain a wireless network in a safe, efficient, and economical manner to serve the needs of society. So that's kind of hard to argue with that. So our presentation today will hopefully illustrate how compliance with industry standards will help us to successfully accomplish our mission. So let's go into some of the paperwork right now. Rules of engagement for basically our industry are governed by regulations, codes, and standards. On the left, we have the regulators, which is federal law, FCC, FAA, and OSHA. In the middle are the building codes. That's local and state law. So building codes for each state are based upon the International Building Code, or IBC, and that's adopted by the local state jurisdictions as law. Within the IBC, it references the TIA 222 standard, which governs structural design and analysis of towers. So once that's adopted by the IBC and adopted by the state codes, the TIA 222 actually becomes part of the building code as law. The consensus standards on the right support the IBC and building codes. So you have the 222, which is structural design and analysis. The 322 is construction engineering, maintenance loads, analysis, and designs. They will do your rigging plans. The ASSP A10 is the contractor's construction safety means and methods. And the 5053 is a mounting system classification. So, Justin, question for you. Why do these standards matter?
Yeah, Dave, thanks. You know, I like to look at why these standards matter as kind of what our forefathers really helped bring together. We're standing on the shoulders of those that came before us and using their expertise to really grow this industry into something even more mature from a quality standpoint and through quality a more safe and efficient industry. The standards provide requirements for proper design and installation. They are developed by relying on that past expertise and continued expertise from those within our industry. They do help create a safe environment by being frequently updated and refined, and with each new release based on industry practice and implementation. The standards really do help our contractors to obtain permits for construction for tower owners and every other daily activity they need to do to give us a robust network that supplies society. As well as the post-modification inspection, which is a PMI, and a post-installation inspection, which is a PII, that we will be diving into much deeper further in the segment here.
Thank you, Justin. All right, moving on, let's talk about the hierarchy of all these components that we have to deal with in our industry.
Yeah, so this is, I want to note that this slide is illustrative. It is not all inclusive. We'll let you all, this will be disseminated at the end of the webinar here, and you can digest it as you see, but just to touch briefly on it, it's a hierarchy of how we kind of get our standards, regulations, and how they all incorporate together. If you think of it as a pyramid at the bottom, you start with maybe some planning advisory notices, which you can find at tifonline.org or at Nate Home. They both supply great information. It's really some great educational resources that help us with our industry. On top of PANS, you then have white papers that, that takes further education and development, really helps to start refine and disseminate more information. Those lead further into the standards that, really do govern our industry. And standards lead up into codes, and we'll talk about the International Building Code. And then finally, at the very top, you have the regulations. And again, as Dave said, those are required by federal law.
Thanks, Justin. All right, moving on, we'll be talking about 3 types of inspections: post-installation inspection, PII, post-modification inspection, PMI, and a maintenance and condition assessment, MNCA. But first, let's talk about installation fault. Justin, would you explain to us what we mean by installation fault, please?
Absolutely, Dave. So everyone on this panel cares intimately about this industry and wants to support and help everyone we can. But we want to make this very clear that when we talk about installation faults in this panel, I'm actually going to read this. Installation fault is used in this deck to highlight that an install did not properly occur. This terminology has been used for years to communicate that there is a problem with the install. It was never intended to be placing fault solely on the engineer, the contractor, the manufacturer, the tower owner, or the end user. It was and is intended to show the issue is a problem with the install that may have been due to design, communication, support, or other issues that need to be understood. Please know that using this term is not to disparage any party, but to focus us all on the root cause and how to support each other in effective execution when working within our roles and responsibilities. So what we're truly saying here is we're not looking to point fault, we're not looking to point blame. We're working collegially together to come up with solutions that help improve the quality and safety of our industry as a whole.
Well said. Thank you, Justin. Okay, so Ryan and John, can you please start us off by talking about the PII and the PMI?
Sure, David. So just a reminder that these are required by TIA 222 in Annex N and Annex O. And, it does apply to more than just structural modifications. Any new mount installs, structural mount mods, and equipment installations, right? So each of these has an effect on the tower and its components and whatever components you're installing. And also imperative that there's communication between the EOR and the asset owner to set these requirements up. For example, as a tower owner, we have to navigate landlords and everything. And, typically, we communicate with the contractor directly, but we might not be in contact with the post-mod crew, right? So they might not know specific entry points to perform the inspection, not know certain requirements that necessarily aren't per code, but are required by our landlord in how to access the site.
Yeah, and from a contractor standpoint, the PMI and the PII process, when we engage with the EOR, the asset owners and the end users, it really allows us to be able to close out a site and know that all the documentation that we've provided is good. We've checked all of our boxes, and, it can really actually reduce the need for a retrip, since we're engaging with all the parties that kind of set the criteria for the PMI or the PII.
Okay, let's move on to maintenance and condition assessment. Ryan, please speak to this.
Yeah, so ANSI TIA 222 is not prescriptive. When it comes to the maintenance condition assessment, it's really intended to set a guideline for the owners of these programs to kind of develop their own scope of work. So if we take into consideration like our standard or traditional tower owners, they're going to have a certain criteria that they want captured inside the maintenance condition assessment. And if we look at some of the other where we have maybe hybrid, where it's a carrier and a structure owner, their scope of work for the maintenance condition assessment is going to vary from our traditional tower codes. And the way that 222 does this is you can look in the actual criteria for the intervals and the assessments, which is in section 14, and then you can also look down into Annex J and get even further into the guidelines and almost a semi-reporting structure, so that way the standards can be satisfied. And one thing that was actually, I believe, just published recently, there is a pan out on TIF's website that goes into the maintenance condition assessment programs in a lot of detail that's easy to digest.
All right, thank you, Ryan. Ryan, can we talk about the similarities and differences between all three inspection types?
Yeah, absolutely. So I know a lot of times in our industry, we tend to use the blanket nomenclature of inspections, right? Well, we can say inspections, but where we're talking at today is we're talking about PIIs, PMIs, maintenance condition assessments. Yes, at the foundation, they are all technically inspections, but they are also all very, very different. Where the PMIs and the PIIs, they're going to be very directed at a certain activity that just happened on the tower. Like John said, if there's a structural modification that's happened, an antenna modification that's happened, potentially a new colo is going on a tower, that's where we're going to trigger a PMI or a PII. Whereas the maintenance condition assessment, it is going to be more of your holistic tower inspection from ground level to the top of the tower. And even more so inside of the maintenance condition assessments, we're going to be handling the planned and unplanned maintenance activities, right? So we always know in existing maintenance condition assessment programs, there's going to be planned activities like twist plumb tension activities, potentially replacing members over time, reapplying galvanic coatings. And we're also going to have to deal with some of our unplanned maintenance activities, which could be vandalism, environmental issues, acts of God, and those are all going to be covered in the MC&A.
So question is, who's responsible to procure these three types of inspections?
So typically with the PMI and the PII, that is going to be facilitated by our EORs in conjunction with the end users and potentially the tower owners. And then traditionally with the maintenance condition assessments, that is going to lie with the structure owners themselves.
Any other comments, John or Justin?
No, I would just say
I would just like to point out.
Oh, sorry, Justin. Yeah, just that, when performing these inspections and the contractors on site, if they can identify extra issues like regarding the unplanned maintenance and repair activities, if you're out there for a structural mod, but you see there's other issues with the tower, please let us know, and we can kill two birds with one stone there, and yeah, that helps everyone out. Perhaps gives the contractor some extra scope, and takes care of our infrastructure better.
Great.
And I just want to point out that the TIA 222 does have section 14 called the maintenance and condition assessment section. However, many times their frequently nomenclature in the industry is performing a TIA. We are talking about the same thing when we're talking about the maintenance and condition assessment.
That's the official name, right? All right, so let's get on to some of the more interesting photos that we have here. Some of our best lessons are learned from our mistakes, right? So the key takeaway is to learn from them, make changes so we don't repeat them. So the following slides you're going to see are some examples of things that didn't go quite according to plan. And so these provide valuable lessons for all of us as a team to make sure that our networks are running smoothly and safely. We'll first go over failed safety climb installations and some failed FAA lighting installations. So Ryan, we have 3 interesting photographs here. Care to explain what we're seeing?
Yeah, sure, Dave. One thing that I would like to note first is that safety climbs are they're managed on a tower as a tower appurtenance. Our tower owners do not install them or do not maintain them as a safety device. They maintain them as an appurtenance. And they cannot become a safety device until a competent person inspects them and then kind of brings them into the fall arrest plan for a particular structure. And this is why the installation of these devices is so important. In the far left photo, we've got a safety climb that's improperly installed because we've got spacers on one side and we have a nut on the other side, which is actually causing a gap between the head assembly and the mounting plate. This is not going to perform as it was designed. In the center photo, we have a safety climb where somebody went and they did their best effort to try to make a repair, but they used the improper extension plate and they only used one. So just because you have a head assembly extension plate does not mean it's the correct extension plate. We always need to make sure that we go back to the manufacturer's documentation to ensure that we're installing the correct parts for the correct tower attachment and the correct head assembly. Then in the third photo on the right, we can tell where we probably have improperly sized spacers and a little bit of force was used, and we actually cracked the weld on that top head assembly. John, coming from a structural engineer standpoint, what are your thoughts about having cracked welds on safety climb top head assemblies?
Yeah, not good. Yeah, not good for anybody. So, obviously we want to replace that safety climb ASAP, to create a safe environment for the climbers,
Well, and Ryan, I mean, time is money, right? And granted, a lot of these were caught in that maintenance and condition assessment, but how frustrated have you ever been when you get out to a site that you need to install some new equipment on and you go to inspect the safety climb and it turns out it's tagged out. So now you have to design a different fall protection plan and it's going to take you more time to complete your scope of work. If we had quality closeout documentation, that post-modification installation or that post-installation inspection, we could have had this addressed before you ever got to site.
That is 100% correct, Justin. There are more times than I would like to count where we have issues of showing up to sites, not being able to utilize the safety climb device or the safety climb that is on the tower. And like you said, we have to come up with other means of fall arrest. And it does. It adds time into the job. It adds planning time into the job. And that cost can potentially end up being spread across multiple stakeholders that are trying to get the same thing accomplished.
Great point, guys. Here's another set of photos here. Ryan and Justin, you want to talk about those?
Yeah, sure, Dave. So in the left photo, again, going back to manufacturer supplied documentation, this safety climb actually has the tensioning spring that's supposed to be mounted at the base of the structure, mounted at the top of the structure. The largest issue with this, outside of the fact that it's not been installed properly, is that tensioning spring has hooks on the end as opposed to closed loops, meaning if that safety climb were to see an impact, the likelihood of a failure is very high. The photo on the right is another example of a safety climb that's been installed improperly, because we still have the warding cap / debris cap installed inside of our strand vise, which means we know we don't have the proper depth of cable installed through the strand vise based upon what the manufacturer dictated for this safety climb.
I think it really hits the point, that left one there, of quality leads to safety. If we had quality documentation and a quality install there, it's a much safer environment than having what we have there, where that's quite potentially deadly.
Yep. So moving on, John, we have some cases where an impertinence install damages the safety climb cable. Can you kind of speak to what we're seeing here in these photographs?
Sure. Yeah, I mean, kind of goes without saying, the photos kind of say it all, right? So extremely dangerous conditions here. Rubbing against the steel in that first one on the left, and then the one on the right, the steel and the coax are getting it, you can see. And, you know, just a reminder, you know, not only the life safety issues of those on the tower, but also the general public, right? 70% of 911 calls go through cellular networks. So, you know, being aware of that, you know, those drops in coverage are also a life safety issue. You know, something you don't maybe recognize when we're on the tower or we're designing something new, you know.
Yeah, this stuff is pretty scary from all aspects. For the one on the left, I'm wondering, when they climbed up there and saw this, were they actually attached to the safety climb cable? Hopefully not. That would be kind of scary if you realized you were attached to something that was about ready to break.
Yeah, it definitely goes back to Ryan's comment on the, you know, the safety protection plan, you know, having that competent person make that assessment.
So Justin, we have some pictures here of some FAA lighting. Will you please give us comments on what we're seeing here, please?
Absolutely. And I think this goes towards helping your client helps you as well, is the way I'll state it. So this is regulatory. It's the FAA Advisory Circular 70-7460. Anything that's greater than 7/8 inch diameter is considered an obstruction for top tower lighting. You can clearly see that every one of these has something that's greater than 7/8 inch obstructing it. Point you to that top left picture there. That's a light diffuser or a light shield, whatever you want to call it. It came from good intentions, trying to help farmers maybe not have to see the light all the time. The problem is it does put this particular structure owner into regulatory noncompliance. There's substantial fines that go with that, and there is a safety aspect for the men and women that fly. These lighting is to help prevent collisions and those sort of issues. That top middle picture there, you'll see how the lens is very occluded. It's very dark white, I'll say. This prevents the light pattern from being able to emit the way that it's supposed to, and it does require replacement. In fact, that actually requires a notice to air emissions, a NOTAM, until that lens can be replaced. Same thing with that top right LED picture there. You just have many things obstructing. But I'd like to pose the question to John as a structure owner. You know, John, if I'm on your site and I'm trying to hit this rad center called out, but I notice that I'm going to obstruct your beacon. If I give you a phone call and potentially give you a couple options, would you be opposed to maybe getting me a little more money to take care of two issues with one stone?
Not at all, Justin. One thing to mention, though, I mean, it's very important to inform the infrastructure owner of something like, say, that top right photo. You know, we are responsible to comply with the FAA, and also, you know, with that equipment, we have specific crews that move this equipment. So we want to make sure that we have people that are comfortable with moving that equipment. So before you touch the lighting, even though it does seem something you could take care of real quick, please reach out to the infrastructure owner to notify us of the issue. And then maybe we'll have you take care of it or take care of it after you're off the site. But letting us know if it's not in compliance is key.
Yeah, that's the critical part, and I want to stress what John said there. Do not take the onus on yourself to just change it. There is height regulations, there is lighting regulations that we do have to follow, and if you just go ahead and raise the beacon and put them over their height limit, you've caused one problem trying to fix a different problem.
Yeah. And then sometimes, you know, the RF engineers are sometimes okay with you dropping a foot or two. It won't mess up too much. So again, that's where everyone has to come together. You know, end user, tower structure owner, GC. You know, we all meet and provide the best solution.
That's a great point, guys. A lot of these topics are best resolved when all the stakeholders are communicating clearly. And many times you say, if you see something, speak up. You know, don't leave it be and let it for someone else to find it in their next inspection. So moving on to the next slide here. As a structural engineer, let me advance it here. Structural engineer connections obviously are important. If tower connections are not made properly, the whole stability and structure load carrying capacity of a tower is in jeopardy. So here are some examples of missing hardware on a primary structural connection that as a structural engineer, we do not like to see this because you've lost reliability in that connection. So Justin, will you go through these slides and show us what we're looking at, please?
Yeah, I'd like to point out that these pictures were all taken during those maintenance and condition assessments. So if you think about that, those go on different cycles that meet each program's needs. But this could be years before it's caught to that maintenance and condition assessment. If a properly done post-modification inspection or post-installation inspection had been completed, these issues would have been fixed in a much more timely resolution. Take you to that top left picture there. You can clearly see that's frankly missing half its hardware for that backing plate. Same thing with that top right picture. And Dave, you know, missing hardware is one thing, but you don't have half your hardware that's doing a whole lot here. What does that do to our antennas?
Yeah, the situation is not predictable. You have things that you can't count on trying to carry load, and at full design loads, you're pretty much going to lose that connection. It's just not good. And fortunately, we don't see design loads every day, but these connections are critical. And it goes to this equipment could fall off a tower under design loads if these connections aren't there.
That bottom left picture there, I don't know how to break it to everybody, but tape is not a nut. It doesn't have the same capacity. I don't think there's a whole lot more to be said on that one, but this bottom right one, it bothers me a little bit. I understand that we're trying to hit specific rad centers and azimuths with this new equipment that we're using to help support our communities. But to undo a structural modification, which is that horizontal there that the arrow is pointing to, so that it can fit, it stresses me out a little bit. I go back to John's point. Let's communicate. Let's stop work for a second and take that deep breath and communicate. I'm not sure I know of an RF engineer that wouldn't allow us to go up 6 inches or down 6 inches, relocate that antenna a little bit so that we don't take out that structural member. I mean, Dave, when you're designing these modifications for these structures, did you intend for them to only be connected at one side there?
Absolutely not. I mean, as a structural engineer, this is the worst thing you can see, because now you have a member that's not able to carry the load it was designed for. And you'll have a situation under certain wind directions and design wind load where that leg that was supposedly braced by that member is no longer braced. You could have a buckling failure and cause partial collapse of the tower. So this is something where as soon as you see it, let people know. We can design fixes, we can have things moved around, we can if you can't move the mounting hardware as an engineer, we can have an alternative connection, but to leave it as is very dangerous, and it poses risk to the safety of the people climbing the tower and also to the tower itself.
I do want to point out, we're not here to cause fear or panic. No Chicken Little. We are using these examples as things we have seen, and the underlying theme here is stop, communicate, and let's work the problem together.
Yep. And as you can see, these things have been this way for a while. So that, basically in a calm manner, we just need to correct it and get the structure back to reliability before it becomes a problem. Okay, so let's move on to welding. Here's some examples of good welds I wanted to show you. These are good, acceptable field welds done by competent AWS certified welders. They've been approved by AWS certified weld inspectors. This is a textbook example of what we want to see in field welds that provide strength and reliability. The next few slides are where we kind of fell short on what we were trying to do out in the field. So Ryan and John, can you speak to these pictures, please?
Yeah, absolutely, Dave. So the photos that are all on the slide currently, unfortunately, these were all caught during, or all taken during maintenance and condition assessments. And like Justin said, maintenance condition assessments are on cycles. They may be an immediate thing. They could be spaced out 3 to 5 years, depending on the structure type. And this is where it really goes to be critical to have a PMI done when we're doing any kind of modifications to a structure. A good PMI would have caught these issues pretty much immediately after the structural modification had been completed, and we wouldn't have had to wait until a maintenance condition assessment cycle came around to find these problems. Now, John, from a structure owner's point of view, what are your thoughts when you see welds like this on structural modifications?
I mean, this is why we have CWI requirements, right? So it provides that extra layer and that expertise on the weld itself, right? So, and that also goes to repairing welds as well. As a tower owner, we send crews out, take as many pictures as you can, and we'll get that information back. An engineer will specify a fix. But you know what? That engineer is not out in the field. The GCs are holding the keys to the car here. And, having that extra CWI requirement may provide some extra comfort that maybe everything was not addressed, but the CWI will catch that on the weld and notify the responsible parties, and then create a safe environment for the next climber.
And
Yeah,
just to clarify, CWI is a certified weld inspection, and to be honest, it is required by the American Welding Society D1.1 be performed on any welds that we have in the field.
That's exactly right. So the AWS applies to certified welders and also for the inspections. That's why it's there to promote field quality. So I'm going to give you a few more examples here. I'm not sure what else is to say other than I'm not sure how that.
Yeah. So so another case of a very, very, very poor weld on a structure. Unfortunately, as you kind of progress through these photos left to right, this is attaching a safety device. Well, it's attaching appurtenance to be used as a safety climb on the structure. And it's already been mentioned a handful of times throughout this webinar. This is your pinnacle of let's stop, take a deep breath, communicate with the stakeholders that are involved in whatever project it is that you're doing, and let's come up with a different solution and not do something like this. John, if you got a call and say, this was a structure that you were responsible for, what kind of things would you potentially work through in an effort to avoid a situation like this?
Maintenance and condition assessment program, right? But we also rely on maybe the end user having their crew go to the site and identify these issues, and then we'll take care of it. So that's the thing. Just because this is not something the tower owners spec. This is something we want to be aware of, something that we want to repair right away to make the tower safe for anyone climbing it, right? So, as you said, Ryan, it's not required, but as a responsible steward of the industry, we want to fix these items. We want to provide that safe environment for everyone climbing the tower.
Okay, next up are improperly sized mount and hardware. Ryan and Justin, let's talk about what we see here.
Well, Ryan, that collar mount was too small, man, but I got to get on the air because my client said I got to be on the air today. So I put this collar mount up and I got a really big hammer. Is that good?
No, this is, as funny as it is, if it doesn't fit, get a bigger hammer is not the best motto to use. As we look at the photo on the left, we've done numerous things. Well, one, we put a collar mount up that wasn't spec'd for the size of the pole. And in doing that, obviously, we bent some threaded rod. Justin, because you got a bigger hammer out and you made it fit because we had to get on air, what do you think the performance of that threaded rod is going to be?
It's not going to be able to support the same tension that it would be in plane. But what are we really looking at for a failure here? I mean, it's kind of a cascading failure. And I would argue that it starts with the engineering. And not pointing fingers by any means, but we need our engineers when we're looking at these things to spec the right size mount, because as contractors, while I need to be reviewing my BOM, sometimes I'm moving so fast that double check from the engineer helps me to be more successful when I'm implementing what the solution is for that specific site.
Absolutely, Justin. Just to piggyback on that, a lot of I've seen before, we have a lot of angle leg towers, and a lot of times on the drawings it's just spec the regular mount. No thought is given to the spec of the attachment to the leg, right? So an angle leg attachment is going to be very different than a solid rod or a pipe leg attachment. And, as a contractor, you're just looking at the drawings, you bid it, right? So, the engineers have to be accountable for speccing, the right hardware for each particular tower, because it definitely makes, it doesn't make life easy for those out in the field when generic details are done and that those items aren't specified.
Well, and it comes back down to communication too. If me as the contractor goes out there and I realize it's too small, that's when I need to stop and escalate to that engineer and say, hey, Houston, we have a problem. Because
Absolutely.
Once I start to provide my documentation for my post-installation inspection, the engineer is going to catch it anyway, and I'm going to have to replace it anyhow. So let's slow down and do the right thing.
Absolutely.
Yep, good point. Okay, next up we have some member failures based on incorrect placement of a strut. John, this is information that you're going to be talking about, and we've got several slides here we can kind of go through briefly if you want to just give us an overall big picture over the next few slides we're going to see.
Yeah, again, here we have kind of a bent member, right? So if you're tightening a bolt and, you feel a little yield and everything, you definitely want to stop. And then, typically you don't want to brace back to bracing members, right? You're always wanting to brace back to a leg. So be aware of that. If you find yourself hitting back to a leg, you definitely want to, again, raise the red flag. Is this really what I'm supposed to be doing?
Yeah, and at some point, when you alter the load path of everything, you put a load in that member that wasn't designed for, and that over time it's like bending the paperclip back and forth. You get a failure. The next slide is, you're gonna love this. When I see this one, I just shake my head. Justin, what's going on with this picture?
This is an old tower, to be honest with you. That nut's probably been there for years, so not a reason to panic, but think of the corrosion that's in there. Think of what we'd have to do to fix this. I mean, nuts aren't shims, ladies and gentlemen. They just aren't. We need to slow down, and frankly, this is when you do engage that competent engineer and, hey, Dave or John, you know, we're probably going to have to bypass this flange at this point because can't trust those flanges from the rust and corrosion. Those bolts are probably shot at this point, and frankly, we only have compression from one little nut.
Yep. All right, next we have base plate leveling nut issues. Ryan, can you please speak to these?
Yeah, so not only are our connections on the actual structure very important, but our connections to the earth are important as well. And looking through these 4 photos, it's just kind of, it's a great layout of issues that we could potentially run into when we're doing maintenance condition assessments and things that need to be looked at in base plate and leveling nut connections. So in the left 2 photos, obviously it's pretty apparent we've got some failing grout. In situations like this, we would engage with some of the other stakeholders, see if the grout is required. If it's not, we would remove it. If it is, we would come up with a solution to go ahead and make the repairs, and also make sure that there's no underlying corrosion that the grout may have trapped inside of our anchor rods. The top right photo, we've got a loose leveling nut on a monopole, which obviously is not good because we're disengaging an anchor rod from performing as it was intended, as it was originally intended, because that leveling nut isn't engaged with the bottom of the tower. In the lower right photo, pretty apparent that we may or may not have had grout under the base of this tower at one time that potentially trapped moisture in there and has caused some pretty concerning corrosion.
Yeah, that's good points, good things to be aware of. A couple miscellaneous.
Let me ask you,
yeah,
Dave, if we could go back just a second, sir.
Yeah.
Let me pose a question to Mr. Carr and Mr. Bozzetto. Ryan, you capture this information during your maintenance and condition assessment, and we're all trying to work together on how we can all be successful. And you see you've got the loose leveling nuts. Would you call Mr. Bozzetto and say, you know, I'd be happy to take care of this for you while on site? And John, I would have to wager you'd say absolutely, because, you know, I get a more reliable structure. And yeah, I give a little bit of money to Mr. Carr's team, but it's taken care of.
Absolutely. You know, saves us another mobilization, right? So, I mean, really, I don't look at it as I got to pay another PO. That mobilization, that saves me money, you know? So yeah, absolutely.
Yeah, and when we're in, you know, when our teams are out in the field, we always do our best to make sure, even if it's not our scope of work, if it's something that could potentially affect the structure, the safety of a site, we always make sure that we escalate those to the proper individuals. If they choose to act on it immediately, they do. Sometimes they take it under advisement, but if the information stays hidden, it's simply that. It's hidden information and nobody's aware of it.
Yeah. And then also for the grout stuff, you know, not in all cases do we want to get rid of it. And this is why during a maintenance condition assessment, an engineer also has to sometimes be involved if that height of the base plate to the top of the foundation is too much, right? So this is again where we need multiple parties involved to make a coherent assessment and remediation.
great points, guys. A couple structural issues. One on the left, John and I, don't appreciate this because you always have an angle member where somebody had to trim it to fit. But what you've done is you created, instead of an angle, you got basically a flat plate with some perforations and cuts on one side. It has nowhere near the load carrying capacity it once had. Plus it's got rusting concerns and interaction with whatever is supporting above. And so this is the kind of thing, if the engineer found out about this during installation, we'd welcome a phone call and say, how do we've got this interference, how do we work around it? We'd be more than happy to work on this because having a situation like this is not good. John, you want to talk about the right side?
Yeah, absolutely. So, this is one where, it doesn't look like, I'm not sure, I can't see if a step bolt was used above or below, but obviously we prefer to relocate the step bolt, hack off that attachment point so you can properly attach that sub-horizontal there. So, yeah, just again, sound like a broken record, right? Just communication, let people know what issues you're having, and so we can provide a great fix. And then, the PMI, you'll get a clean PMI, right? So that's what everyone's kind of looking to do. You want to get off this site and onto the next site.
Yeah. All right. So we've got the next slides are our mount installation issues. Guys, we're running into time issues. So if we can kind of speed up presentation a little bit to save some time, I want to get through all these slides for the audience's benefit. So Justin, can you talk about this slide, please?
Yeah, just real quick, guy wires move constantly depending on site conditions. This one, the mount was installed up against the preforms for these particular guy wires. That'll rub and rub, causing damage over time. This is when you stop again, escalate, because you don't want to fail your PMI to your engineer and say, can I lower these mounts by 6 inches and move forward?
Exactly. Ryan, would you speak to this slide?
Yeah, so outside of mounting system classifications, the TIA 5053A also goes into unbalanced and severely unbalanced loading, as well as being able to help identify mounting center lines on, on different styles of antenna mounting systems. And these 3 photos is just kind of, is why 5053A does talk about unbalanced loading, because we've got 2 antennas, 3 radios, all their RF cabling, positioned in positions 1 and 2, or 4 and 3, depending on who you're talking to. And now we've got a mount that is just under being 5 degrees out of plumb.
John and Justin, here's a mount collar not seated properly.
Yeah, I just want to point out that this mount collar did not cause the damage to the underlying monopole. The improper installation of this mount collar caused the damage to the underlying monopole. And John, what does this do for your other co-locators on the site when all of a sudden you've got partially crushed monopole halfway up the site?
Yeah, again, it's just another time crunch trying to get something fixed that, that wasn't accounted for. A lot of times we have multiple people following each other on the same site. So obviously, this does damage to our business as well as our infrastructure, right? We own the tower. So obviously something that we don't like to see.
All right, so we've got some good slides on network service impacting issues. So it's not just structural or safety climb issues, but these are things that impact the network itself. So gentlemen, what do we want to talk about here?
Again, this is where, it'd be nice if some things were identified before on the drawings, and if it's not, some communication back, right? For example, like safety climb standoffs on an existing mount that you're installing, right? And just be aware of where that coax is going.
And damage to twist flex, as funny as it sounds, A round grommet on a square twist flex does damage the twist flex over time, and frankly, we need our microwaves to play so that we have an active network.
Yep. And with a proper PMI, PII process, these issues would have been caught and they would have been addressed before, before anything actually happened to the network.
So Ryan, what about improperly weatherproof devices?
So all of these issues again could have been identified in a PMI or a PII, and obviously we have to weather seal our tower mounted equipment as the manufacturer dictates. Wide open over voltage protection units and unweatherproof RF jumpers could potentially lead to service degradation. And like John said, being that we are now taking 70% plus of all emergency service calls on cellular networks, this isn't just affecting, our young men and women from being able to update a social media post. This is impacting people that could be in emergency situations.
Good point. Next couple of slides are RRH, our grounding. Ryan?
Yeah, just again, going back to the PMI, PII process, and just another note here, if the OEMs engineer grounding locations, they should be used. This could lead to a failure of this device causing a service disruption.
And then the mount movement and torsion issue. What do we see here, Ryan?
Yeah, so in the the left photo and the center photo, obviously not quite as bad as the photos that we had previously in the presentation. But as John mentioned, we really shouldn't be attaching stiff arms or side struts to our horizontal tower bracing. It's not what they were intended for. These should be attached to the leg, which means those stiff arms are not going to perform as they were designed. And we could end up seeing, twisting moments on the leg. We could see rotation of the sector frame, which means now RF coverage is not going to be what it was originally designed. Now, in the right photo, a few more implications there. This type of microwave antenna, that inboard side strut can see forces up to 1,400 pounds. In the event of a straight line, in the event a straight line wind would happen, and that microwave antenna gets removed from its azimuth and we drop link, now we're not just talking about one site that's potentially impacted. We're talking about every single site downstream from that one microwave antenna that could be potentially affected just by the dropping of this microwave link. The other potential is, if the event is catastrophic enough, it could push that microwave antenna into the other coax lines that are running up the structure.
Good point, guys. Okay, so I think this is the last of the photographs. I'm gonna kind of go over a summary of what we touched on today. Again, we spoke about our mission to design, build, maintain a network infrastructure that's safe, efficient, economical to serve the needs of society is kind of a general overarching mission. We defined the framework for our industry of practice, which are regulations, codes, and standards. We mentioned, and this is a key thing, is that people working together cooperatively is key to a holistic process to enable us to safely maintain a reliable network infrastructure. All the stakeholders, from the end users to the inspectors, if we all have a conversation, a lot of these issues can be addressed quickly and increase reliability. Again, having a good process cycle from analysis through maintenance. We spoke about the importance of having the three types of inspections, the PII, the PMI, the maintenance and condition assessment programs. The key there is to proactively identify issues so they can be addressed in a timely manner before they become safety and reliability problems. I like what Justin says. This is not, the sky is not falling. It's basically keep calm, do our jobs, and address these issues to keep the network reliable. another key lesson is to, as we learn things, learn what not to do, let's put that back into our training and education so that we become better and continuously improve. Again, communication, feedback between all the stakeholders is critical to make the process stronger and increase safety and reliability. Gentlemen, you have any other comments at this time before we go to questions? No?
Not for me.
Okay,
Great job,
we've got we have a little bit of time, a few minutes here that we can kind of go over some questions. I'm going to scroll through and see Sandy has kind of taken these questions. Please put the questions in the chat. There's one question there, guys, and I'll read this and then you guys can individually respond to this here. The person asked, in my view, most of the mistakes occurred in an effort to maintain production levels and ensure profitability. As pricing becomes more competitive and jobs are outsourced multiple times, profit margins are minimal, leading to the cutting of many corners.
I'll take that if you don't mind, Dave. My opinion, and it's my opinion on this, but I understand where that's coming from, but accountability here is key. And remember the respect, not only for yourselves as individuals, but your families and wanting to get home. And to have a quality install leads to a safer environment. And PMI, PII are required in the standards. And that really does lead to that accountability. And I get you're trying to make money, but we need to do it in a way that helps us, not hinders us. I think another aspect of this is there is a lack of education and training that we are always routinely having to retrain. That's why we're trying to offer as many resources as we can through tifonline.org, through Nate Home. Great resources to just really take that deep breath and understand what we're doing before we do it. And if you don't know, stop and ask.
Great point. My comment from just from a consulting engineer's point of view, and I'm sure John Wazzetto as a structural engineer too, a lot of times we're involved on the front end designing the specs and the drawings, and there's a time lag between, and sometimes we never find out what really got installed, but we send our drawings out, and it's only until we get the PMI report back maybe that we see a problem. It would be really good if in real time when the contractors in Ryan's teams are on site, if they would just let us know what's happening. We'd love to be able to collaborate and figure out a field-friendly way to resolve it. Engineers aren't always the most field-friendly people. We're trained in the sciences and the technology, but most of us are not out there climbing towers and doing installations. And over my many years of experience, I've had contractors tell me that, why did you do that? You know, you can draw it, but we can't build it. And so you learn to become more field-friendly with your designs, and it actually reduces errors and increases safety, because if Ryan can install it safely, then I've done my job. If he has to figure out what the heck what I was trying to do with it, I haven't done my job.
And David, just to go on top of that, you know, a picture's worth 1,000 words, but not everything, right? So you guys are out there touching the field. You know, engineers might not have all the information. They have some pictures and maybe not the most recent photos. So you guys are on the tower real time, and you know, that's a really valuable tool for, you know, all the other parties at play.
Great point. So we're at time. I don't see any further questions, but if the audience has any other questions, please feel free to reach out to any of us on the panel. And like Todd said earlier, a copy of this webinar is being recorded and will be made available. I would just like to thank everyone for attending this webinar and taking an hour of your time to be with us during this discussion. We hope you found it interesting and useful. I'd like to thank our expert panelists for their insightful comments and discussion. I want to just say thanks and extend our appreciation to all the great field people out there who keep our networks up and running. You truly are the men and women keeping our networks working. You're braving the elements and doing your jobs well. And we can't say enough how much we appreciate you. I'd also like to thank Tiff and Nate for making this presentation possible. So with that, our presentation is concluded. Thank you, everyone.
Thank you.
Thank you.
Thanks all.